Welcome back to the deep dive. So, if you're a developer, you've definitely seen the explosion of AI coding assistants like iFlow. We all heard the promise, right?
Oh, absolutely. Accelerated cycles, automated refactoring, just generating code at scale.
Basically, a magic button to ship features faster.
And look, while that promise is definitely real, the source material we've been digging into is, well, it's pretty honest about the messy reality of it all.
The friction.
The friction, exactly. Those high expectations are kind of slamming into what it's like day to day. We're seeing this global trend of unpredictable code, sometimes just flat out incorrect code.
And a lot of time wasted debugging what the AI gave you.
A ton of time. And these vague suggestions from the AI that you have to keep clarifying over and over, it's frustrating.
That really captures it. If it feels like someone handed you this incredible engine, but the controls are just wrong. We're trying to talk to it like it's a colleague or, I don't know, a search engine.
And that's the core idea in all the analysis we've seen. The flaw isn't the tool, it's the dialogue. We're treating these incredibly powerful, very literal execution engines like they're conversational.
So when you say something like make this better or add more tests,
The AI is just making a statistical guess. It's looking at its training data and saying, what does better usually mean in this context? The result is just bound to be unpredictable because the instruction itself, it didn't have a clear, verifiable goal.
right. So we shouldn't be waiting for the AI to get better at reading our minds.
No, we need to get better at telling it what to do.
We need to get smarter with our instructions.
Precisely. It's a complete mental shift. You have to stop chatting with the AI. You have to start treating it like a component in a really sophisticated system. The developer becomes like a conductor.
Conductor of an orchestra. I like that.
Yeah. You're bringing everything into harmony. The AI, your linters, your test suites, the compiler all to create code that isn't just, working, but is genuinely high quality.
Which brings us to the mission for this deep dive. We're going to explore this framework called precision orchestration. It's all about that shift, right? From just chatting with an AI to conducting it.
Turning that unpredictable assistant into a partner you can actually rely on.
Okay, so let's start at the beginning. If I'm the conductor, what's the first step? How do I set up the stage for control?
The foundation, well, it starts before you even write a single prompt.
Hmm.
Rule 0, and this is unanimous across all the sources, your safety net is version control. Before you start any session with an AI, you have to be in a fresh Git branch.
That feels a little basic, but why is it so important? I mean, doesn't everyone use Git already?
We all use it, but we often run the AI on our main branch or maybe an existing feature branch. The problem is the sheer scale of the changes.
Ah, right. iFlow can change 20 files in an instant.
Exactly. Imagine a big refactor. It changes 20 files.
Yeah.
90% of it is great, but 10% deep in there introduces a really nasty bug or breaks the build.
Hmm.
How do you unwind that one massive AI commit? It's a nightmare.
Because the changes are so fast and so high volume.
That's it. You need Git to be your undo button for
Yeah.
this experimentation. A fresh branch lets you just throw it all away if the AI goes off the rails. Or you can cherry pick the good parts. It's about you keeping final control no matter how fast the AI is.
Okay, safety net is up. Fresh branch. Now, the physical setup. The sources talk about a really disciplined workflow, specifically using two separate terminals. That sounds like more work. Why is that so critical?
It's about fighting what the sources call blind acceptance. It's a psychological thing. You see code that looks plausible, and your first instinct is just to accept it.
Yeah, I've done that.
We all have. The two terminal setup forces the separation. It adds just enough friction.
Okay, so lay it out. Terminal 1 is for what?
Terminal 1 is your conversation with iFlow. That's it. You send prompts, you review the code it suggests. It's your communication channel, your thinking stream.
And Terminal 2. That's the validator. No exceptions.
No exceptions. That's where you run your tests, your linters, your builds. It's a physical and mental separation. It forces you to pause the conversation, switch context, and prove that the AI's suggestion actually works.
I get it now. It stops you from getting sucked into the AI's flow. You can't just trust it. You have to physically switch screens and run a command to verify it against your standards.
It's the conductor demanding a sound check. The AI suggests a fix, but you don't commit. Not until Terminal 2 gives you a green light. That separation is really the first pillar of this whole idea.
That's a perfect bridge to the next section, which feels like the real heart of it. We have our controlled environment. Now, how do we write prompts that actually use this loop? This is about tool-driven, verifiable prompts.
This is the biggest leap in effectiveness, hands down. You have to stop defining tasks with subjective words like clean up the code or make it faster.
Because the AI is just guessing.
It's guessing. Instead, you replace those vague ideas with targets defined by your development tools, things that give you a binary pass or fail.
So let's use that type annotation example from the source material. The vague prompt is something like, add type annotations to my SRC directory. What goes wrong there?
Well, you've given it a totally open-ended task. It has to decide what files to prioritize, what style to use, when is it even done. The result is, it's a mess. Inconsistent, probably incomplete.
But the precise approach uses a tool to define that scope.
Exactly. The precise prompt is, fix the type annotation issues produced by running mypy disallow untyped defs src. Now, you've given the AI a specific line-by-line list of errors from a professional tool.
It's not a creative writing assignment anymore.
No, it's a mechanical task. It's
Wow.
not guessing, it's solving a bounded, verifiable problem. And you can immediately run MyPyGuy again in Terminal 2 to check its work.
That's so much more efficient. Okay, let's apply that to unit tests. The vague request, add more unit tests to improve code coverage. That almost never works well. Why is that?
Because the AI has no idea what your current coverage is. So it just adds random tests. It might test lines that are already covered a dozen times. You get more tests, but your risk hasn't gone down at all.
It solves the surface request, but not the actual problem.
Right. So the precise method has the AI generate its own blueprint first.
Using the .shell command in IFLOW.
Yes, self-generated orchestration. First, you tell it. .pytest coUC cview cov report JSON. That command runs your coverage tool and spits out a detailed report of exactly which lines and branches are missed.
So that JSON file is the blueprint.
That's the blueprint. The second part of your prompt is, now add unit tests based on the coverage report at .coverage.json. Now it's not guessing. It's using a machine-generated list of targets. It's targeted problem solving.
This really does elevate the developer's role. You're not just asking for things, you're designing these little multi-stage execution plans. Let's talk about that really complex third example with Clang Tidy on a C++ project. This is full-on orchestration.
It is, and it shows how you can use the AI to manage serious complexity. You're moving beyond, naive rules like make variable names longer to using professional-grade static analysis.
So walk me through that prompt. What's step one?
First, the analysis tool itself needs some setup files. So you command the AI to run the build setup. cmake-sb build-dcmp export compile commands 1. That creates the files Clang Tidy needs to understand the project.
You're setting the stage.
You're setting the stage. Then comes the directive. Use Clang Tidy to perform static analysis and fix the issues. Use .buildCompileCommands.json for Clang Tidy. It's precise. It's leveraging the output from step 1. The AI's job is to solve the problems that a professional tool finds.
And I have to ask about my favorite part of that prompt, the very human constraint at the end. Don't delete the build directory or I will delete you.
It's funny, but it is so important. It's a critical part of orchestration. You are setting clear, firm boundaries for the AI in your local environment.
Because they can be a bit aggressive with cleanup.
Very aggressive. If that build directory is critical for your next step, you have to tell it. You have to set those guardrails. It's a good reminder that effective communication, even with a machine, requires boundaries.
So we've got verification locked down with tools. But what about style? Architecture. Even if the code passes every test, if it doesn't look like the rest of the project, that's just a different kind of technical debt.
And that brings us to providing a blueprint, using pattern matching. This is what these AIs are truly amazing at.
They're pattern matching machines.
Phenomenal at it. But if you don't give them a high-quality reference, they just fall back on the average of all the code they were trained on.
Which means you get valid code that looks nothing like your project, different naming, different file structures.
Exactly. It technically works, but it feels alien in your repository.
Right.
Let's take that language conversion example. Python to C++20. A vague prompt is just, convert this Python project to C++20.
And C++ has, what, a million different styles? That could be anything.
The output would be a total mess, architecturally. The AI has no idea how you organize headers, your conventions for class definitions, anything.
So the fix is to point it to a good example, an architectural template.
That's it. The precise prompt becomes, use .cppainclude rectopoint.hpp as a reference. Convert this Python project. By pointing to one specific file, you give the AI a concrete blueprint for everything. Naming, namespaces include patterns, file organization.
You're basically saying, write the new code like this. You're transmitting the project's culture, not just the logic.
You're using its pattern matching strength against your own internal standard. It turns the AI from a generalist into a specialist that actually understands how your project works.
This all ties together so well into that final workflow. Let's walk through that sample session, see how this whole verification heavy loop, the full symphony plays out.
Right, this is where the two terminals really come to life. The developer's job is to keep this loop tight.
Okay, so I'm in terminal one, the iFlow session. I've got my clean branch.
And you immediately run the diagnostic tool inside IFLOW. So my IPy disallow untyped defs SRC. This gives the AI its task list right there in the chat.
And then I give the instruction, okay, fix these issues, start with the high priority ones, commit after you finish each major file. The AI gets to work, it fixes dataprocessor.py.
And then it pauses. Its work is done for now. Now the ball is in the developer's court. You have to switch to terminal 2, the validation stream.
3 checks. First, git diff, just to see what it actually changed.
Then the functional check, PyTest tests, because a clean lint doesn't mean it works.
So important. And then finally, any other quality checks, like Flake 8 SRC.
And only when all of those pass in terminal 2 and you've sanity checked the logic yourself, only then do you make that manual commit with a good message.
This makes sure every single piece of AI work is verified before it gets integrated. You're the quality gate.
That is precision orchestration. The AI does the heavy lifting. The developer conducts the process with objective inputs and objective validation.
So what's the big takeaway for anyone listening who's adopting iFlow or something like it? It really seems like you can turn this thing from a source of frustration into an incredible partner.
It's all about defining the collaboration. It's not about giving up control. It's about letting objective tools handle verification and then letting the AI handle the mechanical work of fixing the problems those tools find.
We've moved from having these vague, subjective chats to using objective, tool-driven targets.
And that is the entire difference between frustration and, real sustained productivity. It's giving a highly specialized machine a laser-focused, measurable task.
This has been an incredibly practical deep dive. For everyone out there using these tools, the source material seems to leave us with one final core mandate for this new era.
When you're using the incredible speed and scale of these AI assistants, you just have to remember the golden rule that holds this whole workflow together. Always verify before you commit. That's the key. That's how you maintain quality and control.